Hey everybody, it is video 5.1. Today we are starting a unit on the basics of geometry as we look forward to just kind of making sure we have a foundation for the upper level classes that will be coming your way in the next couple years. This section is about naming different things that are in geometry. So a point is going to be the basis of where we're going to start with for geometry. So a point is just going to name a location. It's going to look like this. You got your little point. This would be called point A. If you have a whole bunch of points that make a perfectly straight line, we're going to call that a line. A line is going to extend on forever and ever in both directions. Make sure that when you write a line, if it's talking about a line, you have an arrow on either end of your line. This would be line L. A line can also be named by any 2 points on the line, such as if you have point B and point C, you could call this line point C. You'll notice that the symbolism here is that you have the line symbol above the letters. Does not have to be line BC. It could also be line CB. That would be another way of identifying this line. A plane is going to be like a perfectly flat surface that extends forever in all directions. Picture it like a piece of paper, a piece of notebook paper that is a flat surface, but it's going to extend past beyond what the notebook paper itself would be. It's really hard to draw these on paper, on the screen, so just picture it as like a square or some other polygon on a paper that's actually going to extend beyond the line, so it goes on forever that way, that way, that way, and that way. This would be plane P, or you can identify it by points that are in the plane, such as plane DEF. There's not a little symbol like the line symbol or ray symbol when we get to that. To designate that it is a plane, you would just say that it's a plane. A segment, or a line segment as it's also sometimes called, is going to be the part of the line that's strictly between 2 points. So a line extends on forever in either direction, while a line segment is ended with endpoints. So this would be line segment. Oh, I don't know why that says plane P or plane DEF. Let me change that. So this would be a line segment. The way you draw a line segment in symbolic notation is you're going to have your line, and then it would be GH. The other way you could say it is segment HG. So you're going to name the 2 endpoints to identify the segment in the line. And then a ray is a part of a line that starts at a point and extends on forever in one direction. So it's just a piece of the line starting at a point. So this would be ray JK. Now, in the line, we said that you could write it either BC or CB. In the line segment, you said you could do either point. A ray is very different in this, is that your first letter here has to be your endpoint that it starts on, and the other letter is going to be further down the line. So if I told you that it was ray AB, you know that you would have to write it as the endpoint being A, and then B is further down. All right. So here's a plane. It's got some lines and some rays and some points on it. I would like for you to name 4 of the points that are on here. All right. So we have point T, point Q, point R, and point S. Right. Those would be our 4 points. I want you to name a line in the figure. So remember, the line only has to have 2 points in it. So we could say there are several different ways you could name this line right here. You could call this line QR. You could call it QS. You could call it RQ. You could call it RS. Or you could call it SR. Or you could call it SQ. So there's lots of ways you could write the line in the figure and name it. Name the plane. We would just say plane. I didn't give myself really enough room. QRS would be one way you could name it. You could name it plane RST. You could name it plane QST. Doesn't matter which 3 points. You're just using 3 points to identify that it is a plane. Name 4 segments. So here's the segment between Q and R, between R and S, between Q and S, and between T and R. So we would say QR, QS, RS, and RT. Now you could also name these the opposite way. You could say that it's segment RQ, SQ, SR, and TR. But these are just two ways of naming the same line. Just like all of these are the same line, it's just a different way of naming it. This is a different way of naming the same segment. Name 5 rays in this in the picture. All right, so you could say, let me erase some of these lines so we can see it better. All right, so a ray has to have 2 points to it, and it's going to have an ending point. So that would be 1. So we could say ray RQ. We could also say ray SQ. You could do them going the other way. You can have this ray, and you could have that ray. So we would have ray RS and ray QS. And then this one up here is going to be the next one. So that would be ray RT. So that's the 5 rays. All right, so an angle, sorry about my letters just showing up there without, I guess my animations aren't quite right. An angle is formed when you have 2 rays that have a common endpoint. That common endpoint is called a vertex, so it would be like this. So you can see that this is a ray and this is a ray up here, and they have a common endpoint. That forms an angle, and this point right here is called the vertex. When you name an angle, your vertex has to be the center letter when you name it. So you could name this angle XYZ as long as Y is the center because Y is the vertex. You could name it the other way. You could say ZYX as long as Y is the vertex. You can name it just by the vertex, which is angle Y. And sometimes they'll not only have letter names, they may also have number names. This is angle 1 as well. Angles are going to be measured in degrees. If you add the angles up, or just depending on the width of the angle, the reason it's in degrees is it goes towards a circle. 360-degree angle is a complete circle. So one way of naming measure 1 here is we could say measure 1, the measure of angle 1 is 45 degrees. So when you do that, you'll have a little m. That means the measure of angle 1 is 45 degrees. A right angle is called a 90-degree angle. Acute angle is going to be less than 90. One thing about a 90-degree or a right angle, even if you're drawing a picture and it may not look like a right angle, if it has this little box in the corner, that means it's supposed to be a 90-degree angle. So if you have an angle with a box in the corner, it's a 90-degree angle. An acute angle is going to be less than 90 degrees. That would look like that would be less than 90 degrees. Obtuse angle is going to be greater than 90 but less than 180. So 180 is going to make a straight line. So that would be a 180. And if this is 90, then an obtuse angle would be coming from that ray to here. This would be an obtuse. It's going to be anything that's wide like that. Complementary angles are going to add up to 90 degrees. So if you have a 60-degree angle and a 30-degree angle, they'll add up to 90-degree angles. They would be complementary. And supplementary are going to add up to 180. So a 90-degree and a 90-degree are going to be 180. Or a 120-degree and 60 degrees are going to be supplementary. All right, so if we have this picture, this figure, I want you to name a right angle in the figure. Okay, so you need a little more information than that. So you would need to know that that is a box right there. So the right angle in here, the ways you could name that is you could name it as long as E is in the center. You could name this angle DEC or angle CED or angle E. 2 acute angles. This one's going to be acute and this one's going to be acute. So as long as E is in the center, you could say angle CEB and DEA. Angle. Or you could say that it is angle BEC and angle AED, as long as E is in the center, because that's the vertex. Two obtuse angles. So if we're looking at it from anything that's greater than 90 degrees, this is going to be an obtuse angle. So we could say that is angle BED, and this one, which would be angle AEC. The other way you could write those are angle DEB. Sorry, I can't write an E. And angle CEA. So this angle and that angle, that's the same angle, it's just a different way of naming it, because it doesn't matter which order the letters go in as long as your vertex is in the center. Name a pair of complementary. Remember, complementary have to add up to 90. So if we know that this angle here in the center, if we know that this is 90 degrees and this is a straight line, that means that this one and this one have to add up to 90 degrees as well. So the pair of complementary angles would be angle AED and CEB. So it's going to be the same thing as those right there. The other way you could write those is angle DEA and angle BEC, as long as your angle E is in the center. Now, because angle E is the center, or point E is the center of all of these angles, that's why you have to name with using all the other letters as well. Two pairs of supplementary. Supplementary add up to 180 degrees. Okay, so we're going to need to take this one plus that one would add to 180. So we could say AEC and CEB would add up to 180. The other one that's going to add up to 180 is going to be this one plus this one. So we could say angle AED and angle DEB. All right, so if you have two figures that are the same shape and size, they are going to be congruent. Congruent angles are going to have the same measure. So if we know that angle 2, the measure of angle 2 is 50 degrees, and the measure of angle 4 is 50 degrees, then we would say that angle 2 is congruent to angle 4. Congruent segments are going to have the same length. And so this is going to be the symbol for congruency. So it's not equal and it's not approximate, it's congruent. Intersecting lines form two pairs of vertical angles. And vertical angles are always congruent. So here's what I mean by two intersecting lines. So you have this line intersecting to this line, and you can see that it makes four angles. So it makes this angle, and it makes this angle. Those would be vertical angles. They're opposite from each other, so they're going to be congruent. And then this angle right here is going to be congruent to that angle right there. So you have two pairs of congruent angles. So in this case, 1 and 3 are congruent, and 2 and 4 are congruent. So let's see, we have this figure. Angle 1 and angle 3 are vertical angles, and angle 2 and angle 4 are vertical angles. If the measure of angle 2 is 75 degrees, find the measure of angle 4. Well, if this one is 75 and these two are going to be congruent, then that means that the measure of angle 4 has to be 75 degrees. When you get to geometry, you'll have a proof about why that happens. For now, you just need to know that it does. So if the measure of angle 3 is x to the 0, then find the measure of angle 1. Well, if angle 3 is x to the 0, then we would say the measure of angle 1 is x to the 0 as well. So I want you to go ahead and copy this figure down in your notes and then click on the link to go to the homework, because you're going to use this figure to answer the questions in the homework. Since I can't make a figure like this pop up on the homework screen, I'll need you to copy it down. So you've got a plane and you've got some lines and line segments inside the plane to answer questions about. All right? Have a good night.